Welcome to this video on understanding the differences between artificial intelligence, machine learning, and deep learning. In this session, we'll break down these concepts in a simple and practical way, especially from an AI and cybersecurity perspective. In this video, we'll start by understanding what artificial intelligence is, followed by machine learning and deep learning. Then we'll look at their key differences, real-world examples, and how they are used in cybersecurity. Finally, we'll clear up some common misconceptions and help you understand when to use each approach. Artificial intelligence, or AI, is the broadest concept among the three terms we are discussing today. When we talk about AI, we are essentially referring to machines or systems that are designed to perform tasks that typically require human intelligence. These tasks can include decision-making, understanding language, recognizing patterns, and solving problems. To make it simple, if a computer system is doing something smart, like recommending a movie, detecting fraud, or even driving a car, it falls under AI. Now, an important thing to understand is that AI doesn't always mean learning from data. Some AI systems are rule-based. For example, a basic chatbot might respond based on predefined rules without actually learning anything new. Think of AI as the big umbrella. Under this umbrella, we have more specific approaches like machine learning and deep learning. So whenever you hear AI, remember that it includes everything from simple automation to highly advanced neural networks. In cybersecurity, AI is used to detect threats, automate responses, and analyze large amounts of data quickly. It helps security systems act faster than humans in many cases, which is critical in preventing attacks. Summary, takeaway, slide narration. To summarize, artificial intelligence is the broad concept of making machines intelligent. Machine learning is a subset that learns from data, and deep learning goes a step further by learning complex patterns using neural networks. The key is to choose the right approach based on your problem, rather than always going for the most advanced option. Machine learning, often called ML, is a subset of artificial intelligence. The key difference here is that instead of being explicitly programmed with rules, ML systems learn from data. This means we feed data into the system, and it finds patterns and makes decisions based on those patterns. For example, imagine you want to detect spam emails. Instead of writing hundreds of rules manually, you train a machine learning model using examples of spam and non-spam emails. Over time, the system learns what spam looks like and gets better at identifying it. One of the most important aspects of ML is that it improves over time. The more data it processes, the better its predictions become. This is why ML is so powerful in real-world applications. In cybersecurity, machine learning is widely used for anomaly detection. It learns what normal behavior looks like in a network and then flags anything unusual. This helps detect attacks that were never seen before, which is a huge advantage over traditional rule-based systems. So in simple terms, if AI is the goal of making machines smart, ML is one of the main ways we achieve that goal using data. Deep learning is a further subset of machine learning, and it represents some of the most advanced AI systems we have today. It is based on something called neural networks, which are inspired by how the human brain works. In simple terms, deep learning models consist of multiple layers of neurons that process data step by step. Each layer extracts more complex features from the input. For example, in image recognition, the first layer might detect edges, the next layer detects shapes, and later layers identify objects like faces or cars. One key advantage of deep learning is its ability to handle large and complex datasets. It performs extremely well in tasks like image recognition, speech recognition, and natural language processing. However, deep learning requires a lot of data and computing power. Training these models can be time-consuming and expensive, but the results are often very accurate. In cybersecurity, deep learning is used for advanced threat detection, malware classification, and even identifying sophisticated attacks that traditional methods might miss. So, if machine learning is about learning from data, deep learning takes it a step further by using layered neural networks to learn very complex patterns. To clearly understand the relationship between AI, ML, and deep learning, it helps to think of them as layers or a hierarchy. At the top, we have artificial intelligence, which is the broadest concept. It includes any technique that enables machines to mimic human intelligence. Within AI, we have machine learning. This is a more specific approach where systems learn from data instead of relying on hard-coded rules. Machine learning is what makes systems adaptive and capable of improving over time. Then, within machine learning, we have deep learning. This is an even more specialized area that uses neural networks with multiple layers to process complex data. As we move from AI to ML to deep learning, the complexity increases. At the same time, the amount of data required also increases. Deep learning models, for example, need massive datasets to perform well. Understanding this hierarchy is important because it helps you choose the right approach depending on the problem. Not every problem needs deep learning. Sometimes, a simple AI or ML solution is more efficient. Now let's break down the key differences between AI, ML, and deep learning in a simple way. Artificial intelligence can work using rules or learning. It doesn't necessarily require data to improve. Machine learning, on the other hand, relies heavily on data. It learns patterns from data and improves over time. Deep learning goes even further by learning very complex patterns using neural networks. It excels in areas where traditional machine learning struggles, such as image and speech recognition. Another major difference is the amount of data required. AI systems can work with minimal data if they are rule-based. Machine learning needs a moderate amount of data, while deep learning requires large datasets to perform effectively. Finally, complexity increases as we move from AI to ML to deep learning. Deep learning models are more powerful but also more resource-intensive. Understanding these differences helps you decide which approach is best for your specific use case. Let's look at some real-world examples to make these concepts more concrete. Artificial intelligence includes systems like basic chatbots that follow predefined rules. These systems don't learn but still perform intelligent tasks. Machine learning is used in applications like email spam filters and recommendation systems. For example, when Netflix suggests movies or Amazon recommends products, that's machine learning at work. Deep learning is used in more advanced applications like facial recognition and voice assistants such as Siri or Alexa. These systems can understand images, speech, and natural language with high accuracy. In cybersecurity, these technologies are used to detect threats, analyze user behavior, and prevent attacks. Deep learning, in particular, is very useful for identifying complex attack patterns. These examples show how AI, ML, and deep learning are already part of our daily lives, often without us even realizing it. In the field of cybersecurity, AI, ML, and deep learning play a critical role. One of the biggest challenges in cybersecurity is the sheer volume of data. There are millions of events happening every second, and it's impossible for humans to analyze all of them manually. This is where AI comes in. Machine learning helps by identifying patterns and detecting anomalies. For example, if a user suddenly logs in from a different country, the system can flag it as suspicious. Deep learning takes it further by detecting more complex threats, such as advanced malware or zero-day attacks. These are attacks that traditional systems might not recognize. Another important benefit is automation. AI systems can respond to threats instantly, reducing the time it takes to stop an attack. Overall, these technologies make cybersecurity systems faster, smarter, and more effective. There are several misconceptions when it comes to AI, machine learning, and deep learning. One common myth is that all AI systems learn automatically. That's not true. Some AI systems are purely rule-based and do not learn at all. Another misconception is that machine learning and deep learning are the same. While they are related, deep learning is just a subset of machine learning. People also assume that deep learning is always the best solution. In reality, it depends on the problem. For simpler tasks, machine learning or even basic AI can be more efficient. There's also a belief that more data always leads to better results. While data is important, quality matters more than quantity. Finally, complexity does not guarantee success. Sometimes, a simpler model performs better and is easier to maintain. Understanding these misconceptions helps you make better decisions when working with these technologies. Choosing between AI, machine learning, and deep learning depends on your specific use case. If you have a simple problem that can be solved with predefined rules, then basic AI is sufficient. For example, a rule-based chatbot. If your problem involves identifying patterns in data, then machine learning is the right choice. This includes tasks like fraud detection or recommendation systems. If you are dealing with complex data such as images, audio, or natural language, then deep learning is the best option. However, it's important to consider resources. Deep learning requires more data, more computing power, and more time. So instead of always choosing the most advanced option, focus on what is practical and efficient for your problem. To summarize, artificial intelligence is the broad concept of making machines intelligent. Machine learning is a subset that learns from data, and deep learning goes a step further by learning complex patterns using neural networks. The key is to choose the right approach based on your problem, rather than always going for the most advanced option. Thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe for more content on AI and cybersecurity. Stay informed, stay secure, and I'll see you in the next video.